See the doubly linked list. Doubly linked list. Inserting node after given node. Inserting a node after given node. So here we'll take the linked list, doubly linked list as usual. So this is first, this is last, and there are references, both way references. Now this is suppose 25, 39, 11. Suppose these are the data items. Now I have to insert a node with data of suppose 22 after a reference node with data 39. So first what I have to do, create the node nd 22 and this is nd. Now search for 39. So how do you search for 39? Take current, first refer to first node, check whether this key value of the reference is matching with this. If not, go here and matching, stop. If no matching, if the required reference node is not there, we have to insert at the end. So that is the logic. So suppose the general case is the required node is found. General case is the required node is found in the middle. This is the general case. So current is here. Now I have to insert this node in between this 39 and 11 because after a given node. Here I have to insert. To insert this, first what I have to do is modify this modify the references of ND. The first step here is modify references of new node. So what modification we have to do? Make this point to this and make this point to this so that it is inserted in between. Now how do you get address of this from here? So this nd dot next equals to, how do you get this from here? What is that? Current next. So this is one step. So when I do this, this link is established. Now I have to establish this link. How do you get this? This is current node itself. What is this? This is nd dot previous. So nd dot previous is current because current is referring to this. So this will be now this will be pointing to this. This is pointing to this. So that we have done. Now next thing is this node, because now previous node of this is the new node. So this previous field should refer to this. How do you get this? How do you get the address of this or reference to this? From current I can get. So current next. Current next means this one. This node. Current next is this node. But which part of this node I have to modify? This part, which is previous. Current next previous equals to nd. So when I write current next is this node, previous is this one, is referring to new node. Next, current next should refer to, this should refer to the new node. So current next equals to nd. So these are the four changes I have to make. I have to modify the previous and next pointers references of new node and next reference of current node, previous reference of current next node. So these are the changes we have to make when the required node is found somewhere in the middle. Now suppose if the required node is not found, that is a special case. Required node is not found. So suppose if I'm taking reference node as 45 instead of 39, 45, then I'll not be finding. Or suppose if the reference node is 11, so the current will be this. So if the reference node is not found and reference node is found as last, both will be same, because what is our aim? When the required node is reference node is not found, it should be inserted at the end as last node. So if the node is required node is found at last position, then also we have to insert at the end. If the required node is not found, then also we have to insert at the end. So the generic case, these four statements of generic case will check whether they will do the required job when the required node is not found, or when the required node is last node. So when the required node is last node, or if we are actually not finding the node, so this new node should be inserted as last node. This is nd. So nd dot next is current dot next. That will work fine. This statement will work fine. nd dot previous equals to current. This will also work fine. But the problem come with this. Current dot next. Current dot next is none. So there is no current dot next. When there is no current dot next, we are trying to refer previous. So this gives error. So the generic logic is not suitable for special case. What is that special case? The special case is required node, required reference node not found. This is one thing. Or the same special case is applicable when the required node is the last node. The required node is the last node. Is the last node. So this is these two special cases. So what we'll do is, when current is reached beyond the list, then required node is not found. When current is referring to last, required node is the last node. In that case, this logic will not work fine. So for that, what we have to do? What is the statement? This is nd. Now nd dot previous, because this is going to be the last node. So for special case, what we have to do is nd dot next equals to last. So this refers to this. nd dot previous, sorry, not next, it is previous, because this is previous. So this is previous. nd dot previous is last. Then so when I say nd dot previous, it points to this, and this should point to new node. So which is nothing but, how can I do that? nd dot, sorry, not nd, it is last node. So last dot next equals to nd. Now the both pointers are modified. Now this is no more the last node. The last node is this. So the statement I have to write is last equals to nd. So these are the three statements for the special case. These are the four statements for general case. One more special case is there. After we write the code for these two, we'll see that. So here the code what we have to write is insert after given node. So this is singly linked list, I think. So we have to go to doubly linked list. So this is insert node at the end. Insert node after given node. Here we take this two parts as it is without any problem. So whatever may be the insertion, the minimum thing, the compulsory thing what we have to do is read the node, read the data and create the node. Insert node after given node. After given node. So this minimum thing we have to do. Next node is created. Now traverse. So reach the required node. So reach the required node. So how do we reach the required node? For that, current equals to self dot first. So making current point to the first node till we find the node or entire list is exhausted. So current not equals to none, means if list is not exhausted, proceed, or current the data required node is not found. So this actually we have to read the key value of the required node. So ND, uh, what required ND RND data. So this is required node data. So I'll say int input enter data of reference node. So that is read, and now I have to search whether current dot, if the required node not found, or if the list is not exhausted, proceed. So if the required node is found or list is exhausted, stop. That is what the loop says. So what we have to do, proceed. Current equals to current dot next. So this when the loop is terminated, this loop is terminated when the required node is found or list is exhausted. List is exhausted. So list entire list is exhausted. So here list is exhausted or required node is found, it will be repeated. So once we reach here, we have to differentiate between the two. So if first what we have to do here, so first we check whether required node not found or uh, whether it is last node. So if current is equals to none, that means it is the required node not found, or if or if current equals to last, means required node is the last node. So these are the two cases. So here uh, when node needs to be inserted at the end, in this case is when node needs to be inserted, node needs to be inserted at the end, at the end. So when node needs to be inserted at the end, so what is the logic we planned here? So nd dot previous equals to last. So nd dot previous equals to last, means previous of a new node is going to point last. Last, now last till then last node next should point to the current new node, and now new node will be the last node. New node will be the last node. And last, when I refer, I have to use self. So that is important, otherwise it will create a local variable. So this is self. So this is the case when the node needs to be inserted at the end. When node is inserted at the end, when the required node is not found, or the required node found is at the end. Otherwise, this is general case. Generic case, required node is at the middle. Required node is somewhere in the middle. In the middle. So for that, the logic what we have to do, first modify the new node nd dot previous equals to current, nd dot previous equals to current, nd dot next equals to current dot next. So this one step, this is nd, this I'm writing nd dot net current next, nd dot previous equals to current. Then now modify uh, the node after the current. So nd dot next dot previous equals to nd, current dot next equals to nd. These are the remaining two statements. Current next equals to nd. Now it is fine. But one more special case is when the list is empty. When the list is completely empty, both of these logics fail. And what we have to do when the list is empty, make first and last point to the new node. That's all. So how do we know whether list is empty? Here itself we have to check. So special case, one special case here is list is empty. List is empty. When list is empty, what we have to do? How we know? If first equals to none, that means list is empty. In that case, first equals to nd, then last equals to nd, and say print uh, the node with data, node with data, data is inserted as first node, because list is empty. So this is when list is empty. Otherwise, don't do anything. If the list is empty, do this modification and stop. Otherwise, reach the required node. This is step 4, reach the required node. Step 4, reach the required node. And to reach the required node, read the key and reach either the list is exhausted or required node is not found. You keep on repeat. Now, the logic for see, when the required node is not found, we have to insert at the end after last node, or if the required node found is the last node, we have to insert after the last. Both cases will be taken care by this. And generic cases, when the required node is somewhere in the middle. So this is the logic for insert node after given node. So always better you take the diagram as I have shown, the logic you build with the diagram, then the logic can be built easily. So now we'll check whether this is executed successfully or not. So first we have to connect and execute the class node, which is a node. So execute this. So execute this class node, then execute this class doubly linked list. Next, now I have to link this. So option 3, link this. Option 3 is when the uh, insertion is after given node, insert after given node. So this I have to execute now. Now when I execute main, now ensure that list is empty. So 5, list is empty. Now I'll insert, when list is empty, I'll insert after given node, suppose 25. When list is empty, it will not ask for reference node. So enter data for new node. So list is empty, it will be automatically added, but there is some error here. We'll check what is that error. So what is that error? Local variable first reference before assignment. So first and last should be uh, the member of the class. So I had to use self. So here I had to say self dot first, self dot first, self dot last. Now after this, I'll display a message that inserted successfully. Print uh, the node with data, data inserted after R&D data successfully. So this is the message I want to have. I'll execute this. So execute main. So 2, 3. So 25 list is empty. It should be inserted automatically. So inserted is inserted as first node because list is empty. Now I'll say 5. So 25 should be displayed. So 25 is displayed. Now after 25 I'll insert. So 3 I'll insert 33 new data of new node after 25. So it says the node with data 33 inserted after 25 successfully. Now if I say 5, so 25 33 is inserted. Now suppose if I try to insert after the node which is not there, it should be inserted at the end. So 3, so I'll say I want to insert 44 after 20. 20 is not there, so it is inserted at the end. So 44 is inserted at the end. Suppose if the required node is 44, required reference node is 44, then also it will be inserted at the end. So suppose if I take 3, I want to insert 55 after 44, then that special logic will take care. So if I say 5, so it is inserted successfully. Now we'll check other options. 1, I want to insert in the beginning. 11, so now when I say it should be 11, 25, other things, now I'll use 2, 66, it will be inserted at the end. Now if I say 5, so 66 is inserted at the end. So all insertions are happening properly. Display is also happening properly. The next option delete will do it in the next